we are now ready to start creating our whitewater simulation. And maybe you have already guessed by now, the whitewater solver must be in a DOP network. So let's start by creating one. I will press Tab and type DOP network. I will also change my out emit null to this whitewater source. And now that I'm here, I will copy this node. I will need this output later. So I will dive into the DOP network. Before that, I will change its color. I will also change its name. I will call this DOP WW and double click on it. So usually when we have been creating simulations, one of the first things we do is create a gravity node. In this case, we won't create a gravity because the whitewater solver has its own inbuilt gravity. So let's add a merge. We will eventually merge some collisions. Then I will create the whitewater solver itself. So type white and look for the solver. I will connect this solver to the merge node. And finally, I will need a whitewater object. Make sure to connect this whitewater object node to the first input of the solver. And this is it. It's really not very complicated. I will go through the basic parameters of the whitewater solver, but consider that most of them will define the look of your simulation, and as usual, it will really depend on what style and what kind of look you're aiming for. But as usual with every single tool in Houdini, the better you understand the tool, the better you will be able to control it. So first of all, let me go back to frame 1. And one of the first things I usually take care of is the domain size. So select your whitewater solver, and under the limits tab, you will find both the limit size and the limit center. And one common practice is to take these measures from our flip solver and channel reference them here. So I will go back to my object context into the splash geometry and look for the DOP splash network. I will dive in, select the flip solver, and in the volume motion, under volume limits, here you will have both the box size and the box center. So right click on the box size, copy the parameter, go back to our whitewater solver, and channel reference that value to the limit size. So paste as a relative reference and go back. This time I will copy the box center, again return to my whitewater solver, and channel reference to the limit center. So paste relative references. So now we are sure that both domains have the exact same size. Okay, so another very important property is the whitewater scale, and this will define how much whitewater will be created. The smaller this number is, the smaller the separation between the particles will be, and thus the more whitewater you will have. So I will start with a value of 0.01, and once we're happy with the basic look, we might increase this resolution. Another thing that you should be aware of, although you may not need to change this, is the foam location. This is the distance from the water surface, and usually by default, the foam will be created where the surface is. This distinction is very important because particles that start to go below this value will slowly transition into a state called bubbles, and particles that rise higher than this location will become spray. So let's take a look at the emission tab, scroll down, and here we will have another very important parameter, which is the lifespan. And this is an approximation of how much each particle will live. So for this exercise, I will increase the lifespan to 8 seconds. And finally, before we create a test simulation, we need to input our volume sources and our emission source And we already have both things ready. So I will jump out of my DOP network. So remember, here is our source volumes. In this case, our velocity and our surface. And this is the output of our emission volume. So this is why I copied this output in the first place. I will go back into my DOP network and I will paste this output under the emission source. Now all I need to link is the volume source. So I will go back. I will copy this out flip simulation, go back to my DOP network and paste it here. So now we should be able to create a test simulation. So press play. And now where we had our volume, we will see particles start to appear. Now I may have gone very low with my particle separation, so I will stop the simulation and I will change my whitewater scale. So I'll start with 0.2. Go back to frame 1 and again press play. Okay, so now we have something happening. And this is why I wanted to use the sphere to source our whitewater particles. I want to show you here on the front view how the particles that are generated above the water surface will start to fall, while the particles that are generated below the water surface should start to rise. So I mentioned that the whitewater solver has its own gravity force. And here, if you click on the Forces tab, you will find not only a gravity force, but also a buoyancy force. And these two tend to be in equilibrium by default. So for now, I will turn off the buoyancy and only keep the gravity force. This time, if I press play, you will notice how there is no rising of the particles underneath the water surface. They're only falling. Also, some of the particles, once they touch the water surface, will start to float and to ride with the velocity from the incoming volume. Okay, now I'm going to do the opposite. I'm going to take away the gravity force and I'm going to increase the buoyancy. Press play. So now notice how all the particles are rising from underneath the surface, and since we don't have a gravity force to bring them back down, most probably they will keep floating and won't ever fall again. So one of the first things that you're going to have to do is balance these two forces. I would recommend to start with the defaults. I will use minus 9.8 or so for the gravity, and the default of 13 is good. Usually I tend to bring it a little bit lower than this, but let's take a look at how this looks and we can tweak this later if needed.